Yes. Why is it not flat? Because it's just a reflection of this part upwards of. Okay, 10. Okay, 11.2. Okay, now let's use this same idea again. Yeah, why did I do that? Okay, so now it's a bit different. Yeah, okay, yeah. Delete everything. Okay, now let's see. Let's say we have y equals to x plus 2 again. And then you get this. Now we want to deduce y equals to mod x plus 2. Now contrast this with the earlier part. Your mod is on the x only. Have attention, please all look up. How do we deduce? Of course, we know how to sketch this. How do we deduce? The keyword is deduce. So, again, we do the same thing. Let's suppose we have 0, 2. Again, you sub x equals to 0 in, you will also get 0, 2. No big deal. Let's say we have a point here, 1, 3. I sub 1, 3, 1 here, I will still get 3. So 1, 3 should be another point. But let us see, if this is negative 2, 0, what happens? When I substitute negative 2 in, interesting now, because substituting negative 2 in is equivalent to substituting 2 into this. Do you know what I'm saying? So, which means I will get sub 2, I will get 4. So I actually get a negative 2, 4. To make it a bit more clear, if I sub negative 1, I will get 1. Maybe I don't use this point. What happens if I substitute negative 1 here? It is as good as substituting 1 here. It's the same. Correct? So I sub negative 1 here, I will get a y equals to 1. So I will get the same y coordinate here. So is it obvious to all of us now that we get this part which is exactly the same as this? No problem, because when I sub x equals 1, 2, 3, 4, 5, x equals 1, 2, 3, 4, 5 is exactly the same. But when I substitute negative 1, 2, 3, 4, 5, it's different. But when I sub negative 1, 2, 3, 4, 5 here, it will be the same as this part. So I will reflect this up for a second. Follow what I'm saying. This part, this section, will be the exact reflection of this area. Do you know what I'm saying? Can? Good? Okay. So let's go on to the example. So we consider straight line. So now let's consider quadratic. If I substitute negative 2 into here, what do I get? I get f2, which means it is the same as here, which is negative 2. You realize that this y coordinate in this new graph is actually the same as this. Am I right? Okay. So similarly, if I substitute x equals to negative 1, f negative 1 is 10. What if I substitute negative 1 here to the mod? I'll get f1. What is f1? It's 0. But you would notice that whatever you get 0, whether you mod 0 or don't mod 0, is the same. So f, this one you will get 4. And let us note if you see these values, so can I just very quickly highlight? Actually, these values remain unchanged. Correct? This part remains unchanged because it's the positive x portion. It remains unchanged. Correct? This portion remains unchanged. If it's 4, it's 4. If it's 0, it's 0. It's negative 2, it's negative 2. Which means it is this part, right? Which is this part, right? This whole section will remain unchanged. Follow? I know it's boring, sorry. Okay, so you see, if the graph is like that, have attention, look up. If the graph is like that, the y equals to f mod x is, the right hand side is retained, and then it's reflected like that. Do you know anything? Yes? Can? Okay. Okay, points of with y values equal to f negative 2 and f negative 1 will never appear on this graph. What is the reason? Okay, I think it's quite obvious. Okay, maybe I don't answer that question here. This whole section is the explanation why the graph is now symmetrical about the y-axis. This whole section just explains it. Because you will see very clearly when x greater than or equals to 0, positive, whether you mod or you don't mod, they are the same. All of it. Very easy. But if x is negative, that means for such x negative, f negative 1 is f1, f negative 2 is 2. So that is exactly what I'm saying. Correct? So it will have the same y, hence it's. Okay, very quickly, summary. Do you need to memorize this? No need, right? No need, okay? Really no need. If you understand what I'm talking about, really there's no need. Okay, let's move on to example 2.